directory traversal. He makes directories, he traverses the directories, and this is unauthenticated. So anybody could connect to your Urbex server and just traverse your whole directory system. And I'm sorry, but every 13-year-old knows that when he's writing an FTP server, he better filters out this stuff. I mean, come on, you can't be serious, but they were. So that's the local root exploit he puts there. And that's actually the phrase here. Yeah. Okay, I think it should be back up. So interesting to note also is that now we don't need to log in because Apple chose to have the RFCOM port 3, which is there for syncing your PDA, to have it open even before you log in. And as Kevin bound it to port 3, we can now connect to it even without that user logged in. So that MAC address is obviously spoofed or changed. So there we have. So that's hello. Oh, there we are. So what user are we? We are user Bluetooth. We'll see this in a minute. Actually, what I use here is AT Shell, which comes with Blue Diving, which is a nice auditing package for Bluetooth. It uses code which actually was written for Blue Chase, which was a project from the Chaos Computer Club in 2003, I believe. I used that code to launch a shell instead of just using RFCOM and using Minicom. Oops, that was my microphone. Using Minicom to connect to the port. So I'll just launch the shell. I launch the local root exploit, and we should be root. That's it. Now we can scan for other devices, compromise other devices. That PC may be within a company or whatever. It may be a Windows PC or something along these lines. Important is, if you update your machine, it's patched. Kevin waited over a year until he published the stuff, so I think that's, he made public the stuff, so I think that's pretty reasonable enough. Oh, another thing. Oops. Well, it's kind of slow, but it works. Well, anyways. I think I pretty much showed the point. Getting my microphone over here. Oh, cool. It worked. So there are the link keys for these devices. We have, that's actually another device. It's not that beef. That was another USB stick. These are the devices that the Macintosh was authenticated to. Now, if we copy these link keys towards our Linux box and drop it in, etc. Bluetooth keys, we can now connect to this device and pretend to be the Mac, and we will be authenticated towards this device. So we can actually use the services. That's about stealing the link key, which I will show afterwards. Also, the concept behind this. So, can we switch to this PC again? Okay, thanks. So, what was funny was that I had this Mac running on 10.3.9. It was patched. It was patched against the local root exploit he used in his previous versions. So he just said, "Oh, wait, I'll just send you another one." And it's actually, yeah, that's important. Watch out for January, because he will make a month of the Apple bugs, and that will be like an O-day root a day. So that's scary. That's Kevin too. That was his girlfriend. Windows Whitcomb, buffer overflows. So we have remote code execution also in these drivers. There's plenty of stuff. There are basic implementation issues, the // there are buffer overflows, there are format string, there's pretty much anything. This special exploit only works 1 out of 4 times because the shellcode is Unicode, that's not the problem, but actually the address is based upon the BD address, and that's somehow is mixed with other stuff, and that changes. So actually the exploit is successful just 1 out of 4 times, but when it works, it works. So actually versions known to us are these. There might be others. They are all patched. The problem with this is pretty obvious. Who in this room knows, and just wave your hand, who in this room knows what version of stack he has installed on a Windows machine, if you use Windows? What stack version you have installed? If you know, wave your hands. You see, that's the problem. Because, and it isn't obvious for me too, I had to look like 5 minutes to find the version number, because it's in some registry key, and whatever, it won't update with Windows Update. Most people believe, well, I have a Bluetooth stack, so, well, it will be updated with Microsoft. No. Actually, most vendors choose not to go with Microsoft stack this time. And it's strange that there wasn't any public bug within that stack, but there was plenty of bugs within third-party stacks. So, that's important. If you update your machine, it won't update the third-party stack. That may be obvious, but it's not obvious for the general user. You have to actually go to the site and download the patch to actually have it running. So I guess there may be a lot of persons within this room to actually have a vulnerable version. That said, Whitcomb was bought by Broadcom, and it's pretty darn complicated to have your Whitcomb stack updated. So actually there might be lots of people that run vulnerable code and they don't know it. But that's nothing new. So, protocol issues. That's, I don't know if you recall him. It's Iraqi information minister. So why the pin is not that important? The problem with UniKeys, how to find non-discoverable devices, random number generators that may be from hell, link keys, reconstructing them, abusing them, reinforce pairing corruption. So, why the pin is not that useful? Actually, this is the authentication logic implemented in the 1.2 protocol. The pin is not really that useful, the link key is. So, as an attacker is after your link key, it's not after your pin. Your pin actually, if it's not hard-coded, it needs user interaction on the other side, and the user will, of course, see that you want to connect and ask for a pin. So that's pretty obvious. The link key is, basically, here's why. The authentication starts. So the link key is authenticated already. Yes, well, whoop, authentication, okay, but that's obvious. Is a link key available? Yes, it will authenticate a link key. That's basically Diffie-Hellman like they do in the pairing. If that's okay, you authenticate it. The pairing, the moment you enter your PIN, is actually here. So if it's not authenticated, if you don't have a link key or the wrong link key, then you will enter your PIN. So that means if we have the link key, we can actually go around the pairing process, which implicates that you actually manually enter a user PIN, a Bluetooth passkey as we call it now. So the link key is enough to authenticate. Important also, the encryption that uses the AO algorithm can be calculated from the link key. So as soon as you have the link key, you can decrypt the traffic, and that's also very important. Also not so obvious is if we have the link key, we might not only connect to the slave pretending to be the master, but we can also pretend to be the slave connecting to the master with the same link key, and it will work. UniKeys. UniKeys are generated by the device. Actually, I have not seen them. Actually, they are for very, very small devices. I hope it's not used that much. They are based on a pseudo-random number generator that may come from hell, as we see afterwards. It's permanently saved and cannot be changed. The problem is A has a unit key. It authenticates to B. Afterwards, A authenticates to C. And because the unit key is the same, B may now decrypt the traffic. That's also why the ZIG clearly does not recommend its use, and it's within the specification. It's just that it's not so obvious, so I mentioned it. How to find non-discoverable devices passively, and that's very important too. We knew Red Fang, we know now that L2 ping works. Our target address is a 48-bit address. I think that's Nokia. Actually, Red Fang has to brute force through all the different BD addresses, and actually waits for someone to answer. To further reduce the space, Joshua found a really slick way. Here's what he does. We sniff on a preset channel and wait for devices to hop by, capture the Bluetooth preamble, extract the channel access code, which is based on 24 bits of the BD address, and recalculate the BD address, so we have this part. Then we extract the error correction field in the baseband header, which is basically CRC, it's a 10-bit field, and we have this part. Now step 3 is assume the first bit 0, that's easy. And what is left is 8-bit. So we just have to brute force 8-bit, and that's pretty easy and pretty fast and pretty reliable, because if we miss a device, no problem, we just start over and we'll find it. That does only work with the sniffer, and we see that's the crutch here, because currently there's just commercial versions, and they are not cheap. You might find them on eBay. But the goal here is, for everybody of us, should be actually to make this technology to sniff available to everybody, and then we see Bluetooth will pretty much crumble down, because what saved Bluetooth was that in order to really dig down in the foundation of the protocol, you need a sniffer. You need to know the hopping sequence, you need to follow it. And it's pretty much security through obscurity, not because of the implementation, not because they didn't publish the ciphers or they did reinvent the wheel, but simply because to actually really audit a device, you have to follow the hopping sequence, and you need to buy a device like this, which is a BPA 105, which sold around $10,000. You may find it on eBay for $1,000 or less. And that's pretty much, if we as a community find a way to actually hop these sequence, to actually find the frequency hoppings. To actually find the frequency hopping sequence. With a software implementation or similar that works out of the box, this thing will crumble down pretty fast, to my belief. So we brute force the 8 remaining bits. So the random number generators from hell. Specification is not very clear about what to achieve or how to achieve it. Actually, the specification is 1,200 pages, and the thing important about ciphers, as we all know it, is pretty much the quality of the pseudo-random number generator. Of course, you can enhance it by hashing and so forth, but you should pay attention to actually get random values. And the part specifying the random number generator is actually this big. And it starts with an introduction, it's like this, and it reads each device has a pseudo-number generator, pseudo-random number generators are used many purposes within the security functions, for instance, for the challenge response scheme, for generating authentication and encryption keys, etc. In other words, we read this, it's really important, so don't mess it up. And then it reads, within the specification, the requirement placed on the random number generators used are non-repeating and randomly generated. Okay, what does that mean? For example, a non-repeating value could be the output of a counter, that is unlikely to repeat during the lifetime of the authentication key, comma or a date and timestamp.